Today, I am going to tell you the motion in the presence of resistive forces. And let's start. We have already introduced the forces of friction, which come from the electromagnetic force between the surface. If we have an object here and put it on a surface on the ground or something, and we exert the external force here, it will find out that there is also a friction force there in the opposite direction. Okay, recall the related equation is first Fs equal to Fs mass equal to steady friction coefficient times normal force. And if the object has velocity, or we say if the object has non-zero velocity, is use this equation Fk equal to mu k times n. And these two equations tell us the friction force is proportional to the normal force and friction coefficient mu s and mu k. In this chapter, we are going to learn another kind of resistance force. Let's think about some question this below. First one is, why do sport cars design with racing body? And the second one is, why can the skydiver reach the speed as fast as he wants? There is air resistance in the air resistance is a resistance that comes from the medium, which is air, as an object moving through it. And we use R to represent the resistance force. And we should divide the resistance force in two parts, which the magnitude of resistance force is proportional to the speed of an object related to the medium. And the direction, the magnitude and the direction of R is always opposite direction of the object motion relative to the medium. Now we have to think. In this definition, the resistance force might not always be the opposite direction to the speed of an object. And here we comes an example. Imagine there is a kite in the sky. Here is the kite. And we have people here. The direction of resistance force is in the same direction with the kite if we lose the line in our hand. If imagine there is one here into this direction. So if we lose the line in our hand, the kite will be pulled to this way, right? And the direction of the object's motion relative to the medium is opposite to the resistance force. The direction of the object related to the medium is, use this. This is the direction of the object motion relative to the medium, which is air. As a result, we can see this definition here can be as a result we can see the definition here can be proved obviously. Is all the direction of resistant force. The direction of resistant force is always opposite direction of the object motion relative to the medium. And this is the R, and this is the direction of object motion relative to the medium, and which is not the opposite direction of the object's speed. And since the magnitude of R is very complex, we only discuss the simple model here. However, we need to know the concept of terminal velocity and the mathematical way to get a value. Okay, here comes the theory. This theory is describe the model that resistive force proportion to object velocity. As a result, we can write down the equation here, which is resistive force is equal to minus b times its velocity. And we can the b here, b is the constant and whose value depends on the properties of the medium and on the shape and dimensions of the object. Okay, and v is the velocity of the object. So the minus in the equation means the resistive force has an opposite direction with the velocity. Okay. And if we can apply the Newton's second law, which is the total force equal to, if we definition the downward direction is a positive direction, so we can say F total is equal to ng minus the bv. Okay, and it must be equal to NA. So we can, and this is the first equation, is Newton's second law. And we know that the A is equal to the dv over dt. Is a change ratio of the velocity. As a result, we can plus And we can see that A is equal to dV over dt. We can apply substitute A with this second equation. Here is Ng minus Bv equal to N dV over dt. Then we both divide the N, and dV over dt is equal to G minus B over NV. Okay, and this is the so-called differential or the ordinary differential equation, which is ODE. And we can observe this equation as V increase the magnitude of R increase, but it will not increase all the time. It will increase slower, because the total the increase of the R is depends on the increase, which is depends on the increase of V, and the increase of V is the acceleration. So the first Ng, the acceleration is proportional to the F. The total F is Ng minus Bv. As a result, as V increase, the F decrease. Acceleration decrease, and it will achieve the velocity that cause total net force equals to 0. Okay, and then the velocity here is called, use the rate one, terminal velocity. Okay, so the skydiver would not achieve as fast as he wants. Would not achieve the velocity as fast as he wants. It will achieve the terminal velocity and do not increase anymore. So, how is the terminal velocity? We can use this simple equation. Is as here assume terminal velocity is Vt. So Ng minus B Vt equal to 0. Because at the terminal velocity, it will not have the acceleration anymore, and it implies that the total net force is zero. So the terminal velocity is decided by n and b. So in the same medium, we can have the conclusion that in the same medium, which is have the same b value, and the object with more mass can have larger terminal velocity. Okay, here is the important thing. First one, important thing. And second one, we would like to solve this equation. And we would like to solve this equation. Ng minus Bv is equal to N dV dt. I will write down here again. Is equal to G. And we jump to the solution of this equation because we do not learn the differential equation in the first year in college. So the V is equal to Ng over B, 1 minus E over N. And we can say that this is the terminal velocity, and we will use T over tau. This is tau, and it's a Greek letter. As tau is equal to N over B. And E here is the Euler number, is equal to 2.718 to A. Okay.